Hi, do you see the beautiful butterfly flying in the screen? Where did this butterfly come from? How did we make this beautiful butterfly? Do you know? It is just made from a flat sheet of paper, just a square paper turning into a nice butterfly. But how did it become? Shall we quickly open it and see? Wow, I can see a lot of folds here. 1, 2, 3, 4, 5. So many folds. It's so beautiful. This pattern, and suddenly it all turns into a nice butterfly. I didn't know that. See, it just turned into a beautiful butterfly. Again, how did it become a butterfly? You have a nice square sheet of paper, right? We should fold this paper. How do we fold it into a butterfly? First, fold across the diagonal. What is a diagonal? This is the diagonal of the square, so you should fold it across the diagonal. Hold this together tight and go gently close to it and keep it very sharp and click. And gently click and always keep a very sharp end. The end is the very difficult one. You keep it very sharp and you're all done. Wow, you folded already into a triangle. A square became a beautiful triangle, right? Now you have another diagonal, right? You have to fold it along that diagonal as well. So you go quietly, keep this on top of it, hold it, and you come and flatten it, pachak, and you make sure that this edge is very sharp, and go gentle and make sure this is very sharp. Otherwise you have to adjust like that, and then you make it sharp. Is it very sharp now? Can we see? Very sharp, very sharp. My God. So we folded it across both the diagonals now. That's amazing. What else should we do now? We have to make one more fold along the edge. This is called edge of the square. This is also another edge, another edge, another edge. So we're going to fold it along the edge. You make it exactly equal. Slide up and down and you click. When clicking, make sure that, hey, are you on the right edge together? Yes, you are. And you make it very sharp. And then you go to the next side also along this edge. You fold it now. One more edge. That's it. I think the butterfly is slowly taking its shape. Who's able to see the butterfly already in the paper just because of some folds? Isn't that amazing? There is some butterfly hiding here, guys. Let's find out. Okay, once all these edges are very sharp, both the diagonals are okay. This diagonal 1, diagonal 2, edge 1 and edge 2. Everything is sharp. Now comes the most interesting part. You have to start folding it. How do you start folding it? You keep it like a diamond. This is a square and this is a diamond, right? And then you gently fold this edge and you come little close. You pretend to fold it, but don't fold it. Don't go like all the way. Like pretend to fold and stop pretending here, and you turn around and you pretend together. You pretend together. And then when you come near this edge, you have to just press it like this. Shall we try it again? So you have to go pretend, and you gently go near it and stop. There you go. You made a beautiful triangle, but this triangle is the body of the butterfly. Who's able to see the butterfly here? That's amazing, right? So now once you make it all flat and sharp and pressed, it's very important to press all the time. Once you press it, and you're going to make the body of the butterfly. So you're going to take one side and gently fold it here. And whatever you do to one side, you always do to the other side, because the butterfly is beautiful and symmetric on both sides, right? Done. And how do you get the head? You have to go take it around under and connect it here, and you make a butterfly. That is amazing. Are you able to see the butterfly now? You fold it here, you catch the head of the butterfly and fold it, and you can like fly after that. Isn't that amazing? You made your own beautiful butterfly now. Can you make yours and take a picture of it and send it to us? We're really excited to see. You can make it out of a color paper like this or just a white paper like this and color it. Isn't that even more exciting? We are all waiting to see your butterfly. For slightly higher grade kids, shall we understand this butterfly a little bit more? This came from a square piece of paper, remember? Just a square piece of paper. And how do you know it is a square piece of paper? Because the side is the same everywhere. All the four sides are of same length, are all equal. Beautiful, right? But how do you know that? You can take a scale and measure. What is the distance here? What is the distance here? If we don't have a scale, how will you measure the distance? You can transfer this edge distance to this side. How do you transfer the distance? You go along and you tilt it until these two edges align up. See, they are aligning up beautifully and they are same distance, so it must be a square, right? If it was something extra here, it is not a square. You can just tear it off and make it a square then, right? Will it be the same even if we rotate this same edge? This is another edge, and you see that it's exactly matching. This is how you make sure that you have a square piece of paper in your hand. Once you have a square piece of paper, you know how to do this magic of making a butterfly, right? It's so simple. But I'm going to ask you another question. This is one distance, right? From here to here. How do you make half of this distance? How do you make half? You could just fold it and you could make half. This is half, right? This is half of what? This whole distance, half of it is this distance, right? That's amazing. You just made half without measuring. And what will happen if you do it one more time? If you fold it one more time, what do you think you'll get it? Exactly. You made the single length into 4 equal pieces, right? 1, 2, 3 and 4. That's amazing. 1 became 2 and then became 4. And then what's going to become after this now? If you fold it one more time, what are you going to get? Shall we try? Do you want to guess? What are you going to get here? Folded it. So every side is folded one more time. So you get 1, 2, 3, 4, 5, 6, 7, 8. 8 equal pieces. Isn't that amazing? You got 8. And what is this pattern, guys? It's a special pattern that we are seeing. We started off with 1 and then we went to 2 and then we went to 4 and then we went to, did we go to 8? And then we went where? What will happen if you fold it one more time? Do you know? You'll get 16. Wow, that's amazing. And it can go on and on and on all the way. These are called powers of 2. And these number, where will it go eventually? 32, 64, 128, 256. It goes on and on and on. By 10 folds, you'll get this magical number. My God, you can make it into 1024 pieces just by folding it 10 times. Isn't that amazing? This is a special number for us digital designers and computer designers. We love these numbers a lot. So here is your challenge. You have a sheet of paper, right? So this distance was 1. And you could have divided it into 2 by doing this, right? This was half and this was half. If I told you I want to divide this into 3 equal parts, how will you do it? Without scale. If you had scale, you can measure it exactly somewhere here and done. But without the scale, if I said I want to make it into 3 equal parts, the edge, how will you make it? I'm really excited to see your creations and you sharing how to do this through pictures. So here is the same beautiful butterfly back again, and for slightly higher grade kids, it's going to teach something more fun. Shall we learn a little bit about area this time? What is area? The same square sheet of paper, we were talking only about lengths and making it into half and 1/4 and so on and so forth, right? But what is area of a square sheet of paper? How many points does it have? I'm really excited to talk about area. So this is a square sheet of paper of distance 1 on one side and 1 on the other side. So the area is 1 times 1, right? So this is 1 square area, right? We call this 1 square. Wow. Length into breadth. A rectangle would have been length into breadth, but square is just side into side. This is area, right? And how much is this area? Woo. The side became 1 by 2 and this side remains as 1. So this area is now 1 times of 1 by 2. This is half of what we started off with, right? This is half. And what about this? Ooh, what happened here? This is 1 by 2 and this is 1 by 2. Oh my god, this became 1 by 2 into 1 by 2. So this became 1 by 4. This is 1/4. So if I were to bring back the original size of the paper, I will have to make 4 of these to make one area, right? Isn't that interesting? Suddenly from one sheet of paper, you started off with 1 by 1 and you went to half and then you went to 1/4 now. How beautiful is that? This is area, right? This is one way of making the area smaller and smaller, and you could have also done like from 1, you could have just gone like this, ta-da. What is this area now? If this was 1, because this is 1 into 1, what is this? Something tells us that this is half the area, right? That is exactly the area of the triangle, right? So it is 1/2 the base and height. 1 into 1, right? So this is 1/2. Isn't that beautiful? So the area of the rectangle, if you do this, is same as the area of this triangle as well. Interesting, right? So here is your challenge. We have the same square sheet of paper again, but this square area is 1. Remember, 1 times of 1. But I want you to make another piece of square which is half the area of this. But I want it still to remain a square. Half of this area, but it should also be square. Both the sides should be same. How is that possible? If you do this, this is half the area, no doubt. But hey, they are not the same. This is twice as this. But the area is for sure half because it is 1 times of 1 by 2. Right? This is 1/2. But I want it to remain a square. How can you do that? This is your challenge. Do you want a tip? You should ask your butterfly again. Remember, the butterfly's fold is very, very helpful here. And let's see if there is something magical that you can get as a clue from this. We are really excited to see your photographs of how you crack this problem. So I want this area to be 1/2. Something times something should be equal to 1/2. How do you get that from a square piece of paper? Alright guys, so the butterfly is here for teaching something more fun for even more higher grade kids, because we love butterflies and mathematics that comes with butterflies, right? So I'm going to open this up again and show you the square piece of paper that we started off with, right? So this is one sheet of paper of one side, another side, right? These are nice numbers, natural numbers. So 1, 2, 3, 4, nice numbers, right? I make 1 fold, I make 2 folds, I make 3 folds, so on and so forth. These are numbers, right? So how many numbers are in between 1 and 2? 1.5? Anything else? 1.1? Whoa, 1.111? 1.11111 goes on. So if you think about it, between these two numbers, there are infinite numbers. Infinite, right? But are there some special numbers which are of interest to us? Or let's see. These numbers are called real numbers. They are real. For some reason they're called real. And now if we start off with, let's say, a square of area 2, right? This is not side but area is 2, which means if my side is x and x, I'm telling x into x is equal to 2. How could that be possible? What into what could be 2? Oh my god. So then x squared is equal to 2. Are you sure? X is then is equal to, a special number called root of 2. You've heard this number, right? But this is where it starts. They did not know how to equally distribute two sides for certain areas. And that's when they said, okay, that's a special number right there. And if you're solving problems already, somebody would say that is 1.414. No, it doesn't stop there. It goes to 4, 1, 2, 3, 1. It goes on forever. Right? There's no end for these numbers. Wow. A number that never ends, but let's say this is 1 and this is 1, then the diagonal should never end, right? The diagonal should never end. You should never be able to measure from here to here. If you put it on a scale, if you just keep zooming in, it never stops. So that's called an irrational number. Wow. Right? So if you see this is just an approximation. Real world geometry is just an approximation. Right? It starts and it ends, but if you really think about it, this distance, if this was root of 2, it never stops at all. Isn't that awesome? Okay, now coming to your challenge. You start with a square sheet of paper, right? And I want to get an area which is half of this. So this was 1 times of 1. Let's say this was 1 width and 1 length, right? This paper. So this area was 1 times of 1, so it is 1, right? I want to make it like half, but I want it to still remain a square. So, but I can't do this because it gets a rectangle. Even though it is half the area, now it's still a rectangle. I cannot do it the other side because it's still a rectangle. I cannot fold it across because it is a triangle now, but I want it a square. I want it a square of half the area. How is that possible? Then I need to make an edge somewhere. X into x is 1/2, right? So x squared is 1 by 2, and what could x be? Is 1 by root of 2. My God, how can I make that 1 by root of 2? Shall we see how to make that? So we're going to make a fold along this edge now. Same butterfly along this edge and along this edge and along this edge and the last one along this edge. So I'm completely closing one side, right? And the other side we know is already there. What is the area, guys? What is the area of this? This is half plus half, which made it 1, right? So this is half plus half. Isn't that awesome? So half and half made it 1. So this distance must be then 1 by root 2, and this is again 1 by root 2. So this makes it 1 by root 2 into 1 by root 2. So 1 by 2 is the area. And what happens if I continue doing that? If I find that center spot again and again fold it one more time, what is going to happen now? What am I going to get? What area is this? I started off with 1 and it became 1 by 2. Now it is 1 by 4. And so you're saying that 4 of these makes this paper. Can we check? It does. That's amazing, right? And if I keep going on and on and on further, what's going to happen? How do I write this mathematically? I really want to write this mathematically. Shall we try? We are starting with a one sheet of paper, right? So this one area, right? This one area never changes, but when you did this special magical fold, it became 1 by 2 on one side, right? On the other side, it became 1 by 4, right? So, but 1 by 4 on this side, but the other side again became 1 by 8. Really? And then what happens after that? 1 by 16, half of that, and 1 by 32. If you keep going on and on and on, where do you stop? Do you know where you stop? Infinity. And that still is 1. Isn't that amazing? Wow, this is an infinite series. Something that never stops, and you still get the number to be equal to 1. So here is your challenge. You know that in this company we make chips, right? We make integrated circuits, very, very smart. And how do we make them very, very smart? We make them count very intelligently. Like how? With 10 fingers, how many can you count? Just 10, right? But we make these chips count more than 1,000 with just 10 fingers. How is that possible? 1,000? Just 10 fingers? How many can you count usually? Just 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. But how 1,000? It goes like this, and I want you to complete it and send us pictures of how you are completing more than 1,000. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and it goes on up to 1,000, more than 1,000. And I want you to find exactly until what I can count with my 10 fingers. And this is how we make these chips very, very smart.